Imagine you have a list of 1 million users. One search algorithm takes a full tenth of a second, while the other finishes in a fraction of a microsecond. By the end of this video, you'll know exactly how to pick the winner every time and avoid the performance traps that kill modern apps. We aren't just looking at code. We are looking at the engineering decisions that high-scale companies like Google and Amazon make daily. Without this knowledge, you'll likely choose the intuitive path that leads to bottlenecks in your production environment. Let's start with the most common method. Linear search is exactly what it sounds like, checking every single item one by one. It's like looking for a specific photo in a physical stack. It's simple, it's reliable, and it doesn't care if your data is a mess. But as the stack grows, the frustration begins. In Python, this is just a basic loop. We iterate through the range of the array's length, check the value, and return the index immediately if we find a match. It's clean, but pay attention to that loop, it's the reason this method struggles with scale. I'll show you why in a second. Binary search is the smart way to look. If you're searching a dictionary for the word Python, you don't start at a. You open to the middle and immediately discard half the book. This divide and conquer strategy is the foundation of high-speed computing. But wait, there's a catch. Here's the iterative version in Python. We maintain 2 pointers. By moving the left or right boundaries, we effectively teleport through the data. Before I show you the speed results, can you guess how many steps it takes to search 4 billion items? Pause and think. The answer was 32 steps for 4 billion items. That's the power of O log n. While linear search grows at a 1-to-1 ratio with your data, binary search stays incredibly flat. This is why your database queries stay fast even as your user base explodes. Surprise! Binary search isn't always the winner. Sorting data takes n log n time. If you only need to search an unsorted list once, linear search is actually faster than sorting it just to use binary search. Professional developers always weigh the cost of sorting before optimizing. To recap, choose linear search for small or unsorted datasets where you're only looking once. Opt for binary search when performance is critical and your data is either already sorted or will be searched many times. This distinction is what separates junior coders from senior engineers. We've covered the complexity, the Python implementations, and the real-world trade-offs. You now have the tools to analyze any search problem. Remember, the fastest code is the code that does the least amount of work necessary. Don't over-engineer small problems, but don't ignore big ones. If you don't master these algorithmic foundations, your applications will inevitably crawl as they scale. Don't let a simple search loop be your bottleneck. Hit subscribe to keep leveling up your engineering craft with Code Assist Pro. See you in the next deep dive.